Thank you, Lai. Ooh, this meeting is being recorded. I like that. Thank you, Lai. Appreciate it. Can everyone see my introduction slide and they can see my video and hear me okay? Shout out if you can. All good? Yeah?
Fine.
Okay. So thank you very much. I'm Doug Matthews. I'm with Leica Microsystems, and some of you might be kind of wondering, I thought this was an Avia software presentation, and it absolutely is. In very, very recent news, just in the past couple of weeks, Avia Software, which was an independent company, was acquired by Leica Microsystems. So we are now part of Leica Microsystems, part and parcel, and Avia is a Leica product. However, in the short term, nothing we have done with Avia changes, and it's still a great piece of software, and nothing's really changing. It's just a little bit of the name on the shirt and the name on the slide, if you will. So I'm Doug. I'm local to Massachusetts, and I help everyone with Avia in New England and New York. And I want to walk you through some introductory slides here and get us started. So we have a lot to talk about and not really a lot of time, so I'm just going to dive into it. I want to agenda for today really is to provide an introduction to Avia, which is available, as Lai just said, in the Neurotechnology Studio. My goals would be to sort of help promote its use, spark some questions, and just see if there's anything we can do with Avia to push the boundaries of the image analysis that you're doing on your own projects. I'll provide an overview of some of the core functionality for new users. So if you've never used Avia, it can be kind of a lot, I think, a little overwhelming for very, very novice users, especially if you maybe haven't done a lot of image analysis outside of, say, ImageJ or something. So I'll try to give you a short overview of some of the core functions, not everything. And then you'll be able to look over my shoulder as I run some tests in Avia just to show you how I use things. And I'll point out a few little tips and tricks. And also along the way, I just want to make sure that I'm introducing myself as your local conduit for getting help and support with Avia. So I think I joined Avia not that long ago, so I don't know most of you as the Avia person, but I just want to make sure that there's people out there to help you. And then the other kind of core agenda items here is one is how to get help with Avia. Now, normally the way I do this is I dive into like demos first, and I show you all about Avia, and it's overwhelming, and by the end of it, 55 minutes later, the computer's crashed 10 times, and everyone's crying, and I'm crying, and it's just terrible. And I never get to this really important part, which is how to get help. So we're going to do that first. Then I'll show you the basic elements and mechanics of Avia, and then I'm going to I've chosen kind of, not really at random, but 3 what I consider essential tools in Avia. The 3D object analysis recipe, the 3D neuron analysis recipe, and something called the pixel classifier, which is a machine learning image optimization tool that we use. If we get to all 3 of these today, I'll be super, super happy. But I know if you have something else you want to talk about that is urgent or questions come up, please it's more important that we get some questions answered for people than me showing off how to use, I can do this anytime. So the unfortunate thing is that the list of things I can't show you today is way longer than the list of things I can. So I just want to point these things out because I don't want you to walk away with the impression that Avia only does 3 things. It doesn't. It does 2D recipes. We have lots and lots of 2D analysis and recipes, colocalization, object classification. This is great for like spines and stuff like that. There's tons. I could spend 2 hours just showing you advanced tricks for 3D rendering, virtual reality, if you wanted to do that. Deep learning, these things I'm not sure that, well, I don't think you have deep learning on your system, but again, this is another huge aspect of Avia that can be added to Avia, but it's a huge presentation all in of itself. Cell analysis recipes, advanced recipe management, object editing, tracking, lineage editing, and even things like how to do advanced tricks for importing and exporting. There's so much to do. Even down to 3D printing of data that we create in Avia. So maybe it'll be good topics for other events or sub events that we can do along the way. or if anyone sees something in here that is particularly exciting, we can circle back and do that. So first is how to get started and how to get help using Aivia. So this is the first thing I want to talk about because it's really the most important. If you fell asleep for the rest of the presentation, at least you would be able to go back and find us to get some help. So first things first, see Lai, right? Lai is managing the facility that has Aivia in it. So you can, as Lai said, locate it yourself and it's free to use. I didn't even know that. But there's a great package installed on a high-end workstation there. So just talk to Lai. Don't be shy, come out and speak up, and he can get you started using it. Once you are situated in using it and you're realizing that you don't know how to do anything, then you can come see us and access some of our resources. So aviasoftware.com. I'm not trying to like pull a fast one and say go to our website, but I do say that our website at aviasoftware.com is trying to, it spends much more time trying to tell you something than sell you something. Like, yes, there's information about our product on there, but we also have the Avia Wiki, which is like documentation, white papers. We have a good collection of videos and webinars there. If we have any live events that you want to register for, we have them frequently. That's a place to do it. You can download demo images to practice on. We have a free version of Avia called Avia Community that doesn't do nearly as much as what I'm going to show you, but it does a few things, and you can download that for free, and all sorts of stuff. The other place to go is once you're really into using Avia and want to see some other ways to do things, our YouTube channel is very well curated and very well maintained, and we keep all of our important webinars, how-to videos, online workshops, all on here. So I really encourage you. I don't really know, like, the link is kind of a weird link, but just go to YouTube, Avia Software. It's not hard to find. And it's really essential. I think every tool we have, every strategy we use, every application, there's usually more than one video on that topic available to you. So you can find 15 different ways to use the pixel classifier on our YouTube page. The other thing I'll just mention is that the AI Microscopy Symposium, this is in a series of events we've been running. The videos are all recorded and saved on the YouTube page, but these are invited academics who come and speak on their projects that use AI, so it's artificial intelligence, and the AI in Avia stands for artificial intelligence, using AI tools, whether it's deep learning, machine learning, or something sort of in between, actively using on their projects. These are excellent, excellent talks. They are not Avia specific. Like, in fact, I don't think really any of them are about Avia. It's often people using maybe competitors' products or people who are building their own solutions from the ground up. But we just want to promote the use of these artificial intelligence-driven tools in image analysis just to get the word out. We think that's a good thing for everybody. Oops. And then you also have layers of local and specialized support from the Avia team and now Leica Microsystems. So I will be your first really point of contact for questions that are concerning Avia. You can email, call, text, just come find me. Obviously, my contact information will be distributed to everyone. Don't be shy, really. My only job is to kind of help people in this territory get the most out of Avia. We also have some other application technical specialists, Hoyen and Quinn. I don't think they're on the call today, but they are in our Seattle office, and they are just the absolute sort of killers for as deep as you want to go, as advanced as you want to get. Hoyen and Quinn can take care of the questions. And then now coming on up, we'll have support from our local Leica Life Science Research team. Some folks are on the call today. I put a couple names up here. These are the advanced workflow specialists and account managers who you might see in the neighborhood. I apologize to anyone on the Leica call here if I'm missing anyone. I'm not totally familiar with exact coverage here. So what is Avia? It's software. Avia is an innovative, complete, multi-dimensional visualization and analysis platform. We use a combination of artificial intelligence and non-artificial intelligence image processing tools to simplify some of the key steps in analysis and just help you get better answers and better quantitative analysis from your data. We do a lot of stuff right now, and the list is huge. And again, we can't talk about everything, but I just want to give people sort of a sneak peek, at its very core, if nothing else, Avia is a great 3D, multi-D visualization tool. So if you want to render large data sets in 3 dimensions, create movies and visuals, Avia is very, very powerful at doing all that. We have things like virtual reality. I don't know if you guys have the VR set up. I have a kit. I can always happy to bring it in and test it out with you, just kind of for fun. But we spend a lot of time also just doing different ways to do traditional image analysis. This is an example of someone using the pixel classifier on some MRI data, I believe, and just defining areas of interest versus background areas, and then letting machine learning algorithms kind of take control and help segment those objects out of the background. So if you're into any 3D analysis with tracking live cell stuff, we do that very, very well. So that's available to you. We can do static objects or moving objects. Something we've been working on that I don't know is available directly, but partially at least, is cell analysis. We've been working on looking at 3-dimensional objects with an emphasis on compartmentalization and hierarchical structure of a cell. So that's something that you can find, and that translates also very well. It could be a cell, it could be an organism, right? You could be looking at, instead of organelles in a cell, you could be looking at tissues and cells in an organism too, and the hierarchies kind of translate well back and forth. Hopefully I will get to talk about the neuron analysis since you guys are in the neurodiscovery. This is a great tool for doing neuron tracing and reconstruction. Partially, to a large degree, it's automated and it can really speed up the routines that you may be used to for tracing neurons manually. We also have manual tools, but there's some nice recipes for doing this in a more automated fashion. And then there's a bunch of deep learning tools, which I won't really talk about just because we're not going to have time. And I don't think the deep learning module is available, but this is a large portion of where our R&D is invested right now. So let's get started. Let's actually do something. Let's look at another slide. When you jump into Avia, you'll see these different compartments, different groupings for menus and displays. We use a large window for viewing data. We have some other sub windows for managing data that we have or managing results that we get. And we have a section for adjusting the display, how the data looks. And we have a section where we really get into the analysis, like telling Avia what to get out of this data. So that's a sort of recipe console and section down here. So the steps will be sort of view the data using some of these tools and then detect objects of interest, structures of interest, fluorescence of interest, pixels of interest, whatever. I don't really care what we end up detecting, but we're going to end up detecting something. We're going to have Avia use one of its tools to pull out some sort of structure, and more often than not, we're going to call that an object of some kind. So there'll be a surface, it'll be a mesh, but it'll be an object. We're going to explore some results using a spreadsheet down in the bottom here, which we can table that we can use to calculate different measurements and explore those, sort those, and start making some relationship analysis between those. We might look at some integrated charting that we can use to just plot data, looking for trends. That's all built into Avia. Not sure if I'll have time to get into all of this in super great detail, but I want you to be aware of the sort of general strategy. And then, lastly, you might spend some time creating some cool visuals and video animations. So, view the objects, detect the objects, look at some statistics and quantitative values, and then maybe do some cool animation. That's the general workflow that we use in Avia. I don't want to, software that does a lot is going to have a lot of information to present the user. And, I think there's a little bit of a trade-off with making software that's, so simple and so easy to use, sometimes doesn't actually do that much. Avia does a lot. And so in all of these sections, you'll find all sorts of tabs and things, and I don't want you to be overwhelmed. I'm going to try to separate out things that I think are very, very critical and leave things that are, for later. So if I don't talk about it, it's not that, it's not important. It's just in the constraints of time, we have to organize things and prioritize things. So we might talk about some annotations, a spreadsheet, and the video animator in the bottom section. We're going to certainly talk about the recipe console and the pixel classifier, but we might not get to all of the 3D tools and all of the charts and all of the enhancement tools. And then even just looking at, I'll show you in a minute, the menus here will have all these different tools along the side. If I get to the Neuron editor today, I'll be happy. And that's just really scratching the surface of some of the cool things we can do once we create some objects. So we're going to look at, go right into Avia now, look at some basic file management, image management. So I'm going to flip over to Avia. Everyone's seeing Avia. Lai, can you just confirm for me you're seeing this Avia screen? Or somebody?
Yes.
Yes, okay, sorry. It used to have a green border around on my screen, now it's gone, so I just freaked out for a second that you guys were seeing nothing. So opening files in Avia, Avia supports most of the major commercial file formats directly, so you don't have to worry about necessarily exporting them. There's a few we don't support or don't support fully, but most of the major ones, the Zeiss, Nikon, Leica, Olympus, all that kind of stuff will import natively without doing anything. So, but if you want, just open up a file and it brings you right into, basically it starts out in a 2D view of Avia. So this is our image here. It happens to be a Z-stack. We can tell because it has a Z-stack slider. I'm going to jump back to this one here. This also is a Z-stack because it has a Z-stack slider. It's a two-dimensional view. I have a little image explorer, a list of the images that I have open down here. I don't need to look at those right now, so I'm just going to close that out. Over here, I have my controls for adjusting the contrast and visualization. That's just the channel data. This is the raw data, right? This is just what comes off the instrument that you use to acquire it. I've got some stuff for objects. I've got some stuff for 3D settings, and I've got some analysis tools down here. This is what we're going to be getting to shortly. But just to kind of clue you in, when you start up Avia, a two-dimensional view is presented. You can scroll through. If you have a time dimension, you'll also, of course, have a slider for the time dimension or anything else. This little cubic box icon up here is a switch to the 3D view. And again, Avia is a very nice, very fast 3D rendering software for large, complex data sets. It does an excellent, excellent job getting a quick responsive result. So we have some tips and tricks on how we do that, but drop into your 3D view almost right away, and you can start exploring things in 3D. You can use your mouse to zoom in and out. You can use your mouse to pan and drag and to rotate. It's pretty intuitive and it's pretty straightforward. Controlling the contrast and adjustments of the raw data is up here. We can just activate, visualize channels on and off. We can adjust their contrast up and down, make them brighter and darker. This is all fairly standards. Every piece of software has something like this. If you need to get a little bit more nuanced and really tweak something with a lot of finesse, we can sort of come into the advanced channel management here and set some interesting minimums and maximums and really explore the contrast. There are also a couple of different viewing modes. Maximum intensity projection is the most common. There's also kind of a composite view, which is more like looking at it in not quite a surface rendering, but more of a volumetric rendering. You may need to brighten things up, but things closer to you in this 3D space will be brighter and visible. Things that are on the opposite side of the object will not be as visible. Compare that to max intensity projection, where even in a worst case scenario, you can still kind of see things on the far side of that object by peering through, because it has some translucency to it. So that's all pretty standard, actually. I expect you've used software in the past that will have that kind of control. But once we get beyond that, we are going to take this channel data and start incorporating the analysis tools, the recipes, and the pixel classifier to generate what we call objects. And objects are true three-dimensional mesh type objects that are our basis for making measurements. Once I have, this one's been done already, we'll do some one-on-one and live in a minute. But once I have objects now, I can start going through and looking at my spreadsheet and looking at measurements of these objects. It's really hard to measure kind of the volume of this green channel when it's just the raw channel data. We really have to get to the point where we have based a mesh or a structure on that before we can start measuring things like the volume or the intensity inside this volume or the surface area or something like that. So those are the basics of what we're going to do. Make sure I don't forget anything here. Oh, I do want to mention also the search bar. This is something we've been working on a lot in Avia. Get out of there. This command up here in the search, if you kind of are stuck and you kind of forget how to do things, you can just kind of type in almost anything up here, and it'll make suggestions, either tools within Avia that relate to neurons, some neuron composer or importing neurons or neuron tools, but it also might take you straight to YouTube videos on how to use the different neuron analysis tools. And it also might point you to the documentation in the Avia wiki to get information about that. So don't kind of forget about this. I think a lot of people do, and even I'm guilty of that sometimes. But if I need to kind of refresh my memory on how something's working, I just type it in here, and this is something that is growing and getting better with every iteration of Avia. So. I think this is. So we're going to go into 3D object detection now. Let me just present this screen up. 3D object detection is what I would consider one of the most fundamental tools that we use. We're going to use something called a recipe, which is just a workflow, a list of ways to help you get these 3D objects out. And it's going to be found in our recipe console, 3D object analysis. And then the breakdown of this recipe, I'm not going to bore you with all the details here. I'm going to take you through this one-on-one, and we're going to do some examples. I do want to make sure I point out a few really important things. When we do this, I'm going to mention this a few times. But
yeah, absolutely. Is it free?
Free money test now?
oh, hi. I'm going to mention the input channels, because selecting the correct input channel is absolutely critical to getting good success. And this is something where sometimes people stumble. And then also when you do regions of interest, there's some little tricks that you have to do that are not necessarily intuitive to get regions of interest to deploy correctly. So I want to make sure we talk about that. So let's get back to Avia. And let's do some 3D object analysis. I'm going to open a new file. What am I going to open? This one's called Beautiful Organoid. Is it? (2D view, 3D view). Now, for whatever reason, this one came in with just the blue channel on, so I'll activate the others. Oh, that is a beautiful organoid. Okay. It also happens to be in composite view, max intensity projection. That's a little wonky. Just the levels are a little bit like jacked on this, so we'll just pull some of these down. Yeah, all right, cool. So this is the raw data, and now what I want to do is use this as an example to segment. I guess let's keep it simple. We'll segment the nuclei on this because you, the investigator, are super interested in counting these nuclei. This is kind of an interesting example too, because some of the nuclei are touching. You can see they're kind of merged together just by the resolution of the scope that was used probably. But we know that these are probably two separate nuclei. So this will also be a good test for correctly partitioning the objects so that they separate. So let's see what we do here. We don't need this, and we don't need this. Under my analysis tools, under my recipe console, I have a whole list of recipes that are available to you. If it doesn't say 3D, then it's a two-dimensional recipe, and it's designed for a 2D image. If it says 3D, we have cell analysis, neuron analysis, but the one I want is called 3D object analysis meshes. I also have one called spots, and that's a little bit confusing, but spots will just give you dots. So identifying objects with dots, which is okay, but it's no fun. Meshes are way cooler, but they can be more computationally intensive. And already I can see even on my computer, I'm running out of GPU memory must be a much bigger image than I realized, but that's okay. Let's just go with it. 3D object analysis meshes is now the recipe I have chosen. And now I'm going to walk you through the steps that we're going to use to detect the nuclei and separate the nuclei into three-dimensional objects. So first and foremost, I said that the most important thing and the thing that people forget to do the most, the thing I forget to do the most, is correctly set the input and the output, right? We need to tell Aivia what channel is it supposed to look at to get this information for us. And then once it creates objects, where do we put those objects? So the input channel is one of these 4 channels up here. And in this case, for localizing the nuclei, of course, I'll use the 405 channel. If I forget to put that in, anything down here that I input is going to be complete chaos because Aivia is going to be looking at the default, which is the first channel. So this often is just hiding right there. You have to expand it out most of the time. And so it's easy just to get into a rush and skip ahead. So if you're just starting out and struggling a little bit, make sure your inputs are being set correctly. The output of the object is going to be a new object set. This is fine for right now. There's no other choice. But as I build up a hierarchy of many, many different objects, you know, the nuclei, the cell membranes, and something else, I might have the ability to populate this data into other object sets. I don't want to overwrite an old or another object set. So I just want to be careful where it goes. And usually I want to create a new object set. And then we need to do some detection and some partitioning. These magnifying glasses are going to be our previews on those steps. But one thing that you may find is, apparently even on this one, which I didn't think it was big, but it's helpful to do just a piece of this data set to begin with using a region of interest. And now regions of interest are good because Aivia will just run analysis or preview analysis on a small portion to test your settings. And then you can turn the region of analysis off and run it on the whole thing. There might be times when you want to use the ROI because you only want to get, you know, one cell or one part of the brain in the whole section. You can use an ROI to define that, but let's just go ahead and start up using an ROI. And it's a multi-step process to get an ROI really dialed in. Step 1 is to see the ROI. So that's the eyeball. You need to turn on the ROI so that you can see it. And once I see it in 3D, I can use my mouse to kind of move it around a little bit and shrink it and expand it. Whoops, not that one. Shrink it and expand it and move it around. So I can grab these little handles, push it around in 3D, and then I can push and pull it. Now, every voxel, every pixel, every little piece that you include in the ROI is going to slow Aivia down or slow the processing down. So the smaller the ROI, the better, but you want an ROI that properly samples your structure of interest. So I'm just going to pull this down to here so we get a little bit of this stuff right in the corner here. And these look like good nuclei to at least tell me whether or not I've got the right detection settings. Now, you would think, since you're seeing the ROI, that Aivia is going to use that ROI, but unfortunately, it's not. So there's a multi-step process here. One is eyeball to see the region of interest, and then these checkboxes here are use the region of interest, apply the region of interest. So if you do not have these checked, Aivia is running on the entire block, the entire data set. If you have this checked, it is just running on this little region of interest and ignoring everything else. That's a subtle little thing that I think we're going to work on getting the sort of button positioning the way we want it. But just for now, be aware that a lot of people experience say, oh, I'm running an ROI and it still isn't going the way I want it to go. Maybe it's not being applied. Sometimes I use this little clip crop tool so that it just shows me just the region of interest. And that way I can just kind of focus, because I lose my attention very easily. And if I have a lot to look at, sometimes I get distracted. So this is a good way to clip it just to show it, just to show me that region of interest. So now the work begins. Now we need to detect these guys and be able to sort of separate the touching ones. So two-step process here. Always work top to bottom. detection followed by partitioning or separation. So detection, there's a preview button here, and it wants to know a few things though. It wants to know about image smoothing, it wants to know about minimum edge intensity, and it wants to know something called fill holes. Whenever you see a red and green arrow like this is a significant start, stop, optional step that you need to think about whether you want to include it or not include it. And I can't necessarily tell you on every data set whether you should include these steps or not include these steps. That has to be determined empirically 9 times out of 10. Sometimes you develop a feel for it, but in this case, image smoothing, we can skip image smoothing. In other words, turn image pre-smoothing, smoothing that image before it does any analysis. We can turn that off completely. So that's skipping the step altogether. Or I can apply one of 4 different filters and then different sizes of those filters. So you have sort of power of the filtration too, right? So things will get smoother and smoother until they're just eroded down to nothing, or just a subtle smoothing step. So I'll leave it on morphological filtering, and I'll just do like a power of 1, the minimum amount of smoothing before we do the analysis. Now this is a good one here. This is a skip remove background or remove background, right? So everyone wants to remove background. I feel like everyone just dives into remove background always. It's really just another smoothing step, right? It's just another kind of kernel operation that may reduce kind of the overall resolution of the image and reduce your quality of measurement. So there's no background really, and this is great. This is about as good as it gets in terms of nuclear staining or cell staining. I don't really see an awful lot of background. I'm sure if we sort of jack up the contrast, it's probably processed somehow or something, deconvolution or something, but there's not a lot of stuff in between the cells. So I am going to make sure I skip the background removal step. But I do always check these. Whenever I see the red and green, I click on it and remind myself, what is it asking me to do? The other important factor is the minimum edge intensity. What's that? Well, there's one quick and easy way to find minimum edge intensity, and that is to quickly toggle back to your 2-dimensional view. I'm going to use my Z-stack until I see my region of interest. And I'm going to come in on this guy over here. And I'm just going to pick one cell or one nucleus. And if I watch the bottom of my screen down here, when I hover my cursor over the edge of this, I'll get a readout of the intensity of that channel. So that's 14,000, 16,000. So it's somewhere in the 15,000 range or something like that. If you have multiple channels on, you'll get data from all of those channels. So it's always a good idea just to toggle off channels you're not playing with at the moment. So 15,000, I don't know, let's try 13,000. Fill holes is, if you have large voids inside, actually there are some voids here. I don't know what this is going to be. This is in cubic microns. I'll just put in 10 for now. It's not going to be a huge factor. And now I want to see how we did. I don't see anything yet because I have to hit the magnifying glass. The magnifying glass is the preview. Avia will generate the preview for frame 1. Often the first one takes a little while, and then after subsequent changes, it'll be a little bit faster. And we kind of see something here. So what do we see? We see something now appearing in the object set settings. These are meshes. These are a preview of the 3-dimensional objects we can extract from the 405 channel. And right now, they're colored green. I don't really care about the coloring. I'll figure that out in a second. But I can toggle off my nuclear channel. I can kind of see, this is what Avia is thinking I'm talking about right now. Now, that ain't bad, but the threshold is a little bit promiscuous there. It's got some space in here that I can improve upon. So all I'm going to do is come into my intensity threshold here, put in like 15,000. These meshes will update. It's a little better. That should be fine. So now I can toggle off my DAPI setting. I can do this. I can toggle that off. So I'll just flip back and forth and make sure, at least approximately, that these outlines, these meshes, are tracking with the objects of interest. The second step is to get them pulled apart so that we don't see them all glued together the way they are here. And that is in the partitioning step. There is an option to skip partitioning, which would be a complete disaster in the case of the nuclei. But if this was like an endoplasmic reticulum, it's all one continuous, object, you probably would just skip the partitioning. You want it to be all connected. You don't want it to be broken up. But I need it to be broken up here. Otherwise, everyone will laugh at me. So we're going to apply a partitioning here. Now, it also is asking for some information from me. It wants to know object radius. It wants to know mesh smoothing factor. What the heck is that? And then minimum edge to center distance. Okay. Object radius, we can figure that out. That's easy. Back to my two-dimensional view and a quick drop over to the Annotations Tool. Annotations Tool just uses a line tool. Click, 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 click. I just drew 3 random lines on 3 random objects of interest, and I'm looking at the length of those lines, 6, 3. So they're probably around 5 microns in diameter, and it wants to know object radius. So the object radius is probably from like 2 to like 4 tops, maybe. Mesh smoothing factor, take my word for it, always put in a value of about 1 to start with. 1 is great. And then minimum edge to center distance, this is sort of saying like from the middle of 1 to the edge of its neighboring, what would that kind of distance be? This less important to measure directly, but I'll just put in kind of like 3 for right now. And let's go back to our 3D view and let's see how we're doing here. Whoops. So the preview for the partitioning is on. If the preview for the partitioning is active with the magnifying glass, what happens is Aivia runs the detection step, which we just previewed, and then it runs the partition step and shows you the combined result. So let me turn off my 405. And now I can see what Aivia is trying to do here. It's trying to break these objects up into discrete objects. And now I get an assessment of like, how am I doing, right? Am I doing a good job, or is it not good? It's pretty good, but I can see it's under segmenting this guy right here. It would be really nice if I could get that, because that's a pretty obvious one. So what I'm going to do is I am going to lower this edge to center distance and see if it will get a little bit more aggressive on the partitioning. It does, and that might be a little over aggressive. I'm not sure if, oh no, this one actually might be, that could actually be 2 nuclei. So you just need to give it a check. You want to find a value, and it's going to be small changes in this value, maybe small changes in these values, to get it to recognize these objects accurately without over partitioning or under partitioning them. And I see a little bit of over partitioning on this. Come back to here. Sometimes I toss it back and forth and I just kind of take a look at it. You'll need to find a happy medium. Don't perseverate over one cell that you can't get to partition correctly. This is just a small sampling. And what I want to do now, though, is turn off the preview. And I want to run this on the whole volume, not just the region of interest. So remember, regions of interest are over here. Seeing the region of interest, oh, you turned it off. Great. Now it's going to run on the whole thing. No, it's not, because you have to disable the apply checkboxes. Now it's going to run on the whole thing. I'm not going to do a preview on any of that because it will take a little while. I'm just going to hit start. And start will now run this analysis recipe with these settings on the entire volume on the 405 channel. Depending on the complexity, the number of objects, the amount of processing that's required, this could take just a second. This could take a few minutes. I do massive data sets that can take an hour to process really complex. So you're putting the processor to work right now. The GPU and the CPU are working overtime to get you these results right now. I just want to say too, I've never actually done the 3D analysis recipe on this data set. So it's not like I practiced with like the other one I had with like the cells and the sort of big green cells. I've done it 1,000 times on that, so I didn't want to use that one. This one is brand new to me, so I don't even know how long this is going to take, which is kind of stupid, right? And I'm keeping an eye on the clock, and it's already 10:45 because time just flies. I think what I'm going to do is do the pixel classifier next, and I'll talk to you after about maybe doing something separate for the 3D neuron analysis. 3D neuron analysis is very similar to what we just did in terms of detecting objects and setting up some of these diameters and radii and setting up some basic parameters about the intensity, except it's specific for neurons, and it will break up neurons into somas, dendrites, and spines and organize them in that hierarchy, which is nice. But the basic premise is similar to 3D object analysis.
Can I ask you a question though?
Of course, yeah, hey, shoot.
Can you align the data sets across time? Let's say you were to record from a few thousand neurons day one, and then you go to day 2, 3, 4. The alignment is a major issue.
It's an issue, yeah. That's a great question, and this is something we still struggle with. We do not have a really robust image alignment tool built into Avia at the moment. We have one that's suitable, I think, for tissue sections. You know, if you had some like a stack in a tissue section, it's not very robust, I would say.
Got it.
The flip side of that is, fortunately, there are a lot of ImageJ plugins right now, Fiji plugins right now, that are excellent at doing that kind of stuff. So I suggest kind of looking at those options first, and then we'll be working on that too in the meantime. But right now, no. It's a good question though. Any other questions while we wait for my computer to crash? So what we will do now while that's going is I will show you, I said we're going to neuron tracing, but we're going to actually skip right over to the pixel classifier. Oh, here it is, it's done. Okay, so that took just a minute, a couple minutes longer than I was hoping, but it's done. So what do we got? We got results. We have objects. So under object set settings, we have these groups, and we have these objects. What are these objects? We can call these are the nuclei from that cool organoid. You can name these. It's important, I think, to name them. Once you create them, name them something intelligent for yourself. But it's as you start building up, because we might build a set of objects from each of these channels, keeping track of them can get a little bit crazy. So what do we get? If we turn off the raw channel data, now we have the segmentation of these nuclei. This is clearly a little over segmented. I need to go back and tweak some of these settings, but it's not bad overall. But I see some examples where it's cutting nuclei into multiples. So it definitely shouldn't do that. But that's just a matter of going back and tweaking some of this minimum edge to center distance and the radius a little bit. I'm quite confident we could easily get some of these much better segmented there. Look at that guy. But what's the point of this? The point is now, if you open up this bottom panel, you can access the spreadsheet, and the spreadsheet gives you a count of all the meshes in this image. There are 524 meshes. Each one has a label and a name, and we can click on one and zoom in on it. We can click on another and zoom in on it. Oh, it's ugly. But you can also now start accessing all the different morphological intensity and other parameters to get quantitative measures. This is a list of these measurements, but you might say, I don't care about any of these measurements. The ruler over here will give you a comprehensive list of all the available measurements. A lot of them are related to the morphology of the object. Some of them are related to the intensity as it relates to other channels. And this is powerful. If you find all the nuclei and you want to know how many of them, which ones are positive for the red stuff, for the purple stuff, you can look at the total intensity of other channels within the nuclear object and extrapolate from there. Position within the image, I think. And then depending on the different type of group this is, you might have different measurements available to you. You can set those up though, and you can sort them. And this is just an easy way. If I want to find, I might want to find the biggest ones or the smallest ones. So sort them by volume. So these are the big guys. But you know, you might want to get, there's probably some little pieces of debris or something in there. So I might want to take those out. So I might just kind of grab, you know, anything below 100 cubic microns, highlight that, and just, you know, you can just delete that. Hit the delete button. Oh, that might take a second because it was like, oh, it's not too bad. And that will take out all the small ones, for instance, or all the big ones, or all whatever. Oop, I took out more than that. I took out more than I wanted to. Should practice that more. But you get the idea. You can find your measurements once you have the objects, and then do some creative. Oh, they're there. Do some creative tricks to sort them and process them. You can also gate them out into separate tabs along the spreadsheet, which helps you when you export them. I just want the ones that were positive for green, just the ones that are positive for red. All that's there, and exporting is really straightforward. So I won't bore you with how to click and export to Excel. Let's jump back and look at the pixel classifier. I don't know if I'm going to have enough time to show what I really want to show on that. So Lai will have to probably talk about what we get out of this and how we want to proceed from here. But the pixel classifier is one of the artificial intelligence tools in Aivia. It is technically a machine learning tool. We have a pixel classifier, which groups pixels with similar patterns, pattern recognition essentially, together and to help us find objects. There's also one, once we have objects, we can use the same sort of strategy to sort them into buckets and classify them according to their shape, size, and whatnot. But the pixel classifier is really a very powerful tool for us. Not to be confused with anything related to deep learning. Deep learning is another side of Aivia that's very, very powerful, but is a completely separate story. And we just don't have time to get into all of that story. But what do we use the pixel classifier for? Let me get this in present. We can use this to mark out from a single, say, for instance, just a single channel image, areas of nuclear, kind of what we think are the nuclei, areas that we think are the cytoplasm, and maybe areas that we think are the membrane. And all we're doing here is finger painting with an annotation tool, a pencil tool on the image, and we're drawing examples. We're not drawing all of them. We're just drawing a few examples of each of these different structures. And Aivia will then create an algorithm that can look for patterns in the pixels you've selected under each class, and then separate them out into essentially new channels, for instance. So again, with 10 minutes to spare here, I'm going to actually let some of the pre-recorded videos do the talking here, but we are drawing an example of what the membrane stain looks like. We've drawn examples of what the nuclear stain looks like. And now an algorithm is being built up and trained. And essentially, we're going to be able to separate out a membrane channel, a cytoplasmic channel, and a nuclear channel, all just from the single channel data, not based on the intensity, because it's all green and it's a similar intensity in the membrane and the nucleus, and cytoplasm's dimmer, but it's based on the patterns, the sort of what the pixels are in relation to their neighbors, what the pixels are, what they look like after certain filters have been applied, like a lot of different filters have been applied. But now you can see we've got a nuclear channel, cell channel, and a membrane channel, all just kind of quickly virtual channels developed out of a single input. And it's cool. We might use this pixel classifier to help us isolate. This is data, I think, from an MRI. And I think someone was asking me the other day about MRI data. So this is an example where we're just using this to segment out different structures of interest within this MRI data. Again, just annotating, finger painting, telling Aivia, this is background paint, and this is something I'm interested in, paint on it. You don't need to draw the whole object. All you need to do is give it enough pixels to give it a sample of what you're looking for. And it can pull out now a channel that could be rendered in 3D. And this channel would be much, much better input for like the 3D object analysis that we just did. Oftentimes you find this all day long in confocal data where despite your best efforts, either because of the instrumentation or because of the nature of the staining, it's very like granular, it's not very regular. We can use the pixel classifier to just paint on here some examples of, this counts as positive, this counts as positive, and these guys count as positive, and now just painting in some background, the purple lines. And the resultant channel, the output of the pixel classifier in this case, will be it's not a binary mask, but it's a much, much more regularized, evened out sample or reconstruction of that original data set. Again, if it's just a binary mask, you would just set an intensity threshold, and you would not be able to get the brightest guys or the darkest guys. You pick one or the other. Even with bimodal thresholding, it's still hard to do. But by just picking out patterns and telling it, solid patterns count and sparse patterns count, you can generate this really regularized version of that. And then again, see if I can get this one. This is taking high contrast or low contrast and high signal to noise and low signal to noise images and getting a more stable channel out of it. So let's see. This is a DIC image, obviously, but painting on here. If you tried to threshold this, you would be just thresholding probably on that white, this bright side, this bright part of the cell here in the DIC image, and you'd never be able to get what's in shadow here. So just training a pixel classifier that all this stuff, don't worry about the intensity, this stuff counts. This is positive. And then going in and repeating the process a little bit for background, and the pixel classifier will be able to pull this out. More importantly, make a few annotations on one image, and then be able to apply that same algorithm to 100 images. And you can see here, this is an example of just kind of cleaning up. It got a little bit too much background. So we're just going through, helping Aivia find that a little bit better. And now we can, we could threshold, measure this, put this into any of our recipes, and use that as a better basis for measuring, the length of the dendrites or processes or something like that. Trying to get that off a raw DIC image, it's kind of hard. It's really hard. You'd have to end up measuring it manually more than likely. So. All right. I really was hoping I would get to do some live demonstrations of that. What I'm going to do is put up my final slide here, which is just an acknowledgement and thank you, and some take-home messages, and then see how we stand on time and things. I hope you've sort of seen that Aivia is a very powerful tool. It's available to you in the Neurotechnology Studio. You should be, feel free to deploy it to help with your projects, your publications, or just like spice up lab meeting. Make some beautiful, renderings and movies and just blow people away, and then everyone's jealous and thinks you're great. And then we are one of the younger softwares on the market. There are other, packages available, and certainly, ImageJ and things like that are available to you, of course. But the benefit of that is we are growing and adapting at a very fast pace, and we are open to feedback, even collaborations with investigators. So if something's on your mind, talk to us directly about that. And it's really surprising how far we can go, kind of being a more nimble and adaptable platform. So help is available, right? Talk to Lai and talk to myself. Don't be shy. Just pick up the phone, pick up the email, and just tell me your question, right? If you tell me what you're trying to do, I'll tell you if it's totally hopeless or if it's possible, and then I'll give you some steps to get started. So that's my conclusion for today. I think we're cutting it just under 11. I want to be respectful of people's time. The flip side is I want to do more with people too. So Lai, I think we should take some feedback on this from the people who are still with us and see what we want to do next, if anything at all.
Okay, sure. Thanks, Doc.
Yeah.
So anyone, if you have any question, you can unmute yourself and ask.
Yeah, well, I just go back to the question I asked. I think that the alignment is a major issue, and it's going to become more and more of a major issue as we are collecting increasingly multimodality data, which would require, for example, in vivo, in vitro alignments or in vivo alignments over days. So I wonder, since you mentioned that you guys, are interested in potentially working with people, if that's a possibility for this particular application, to work on seeing whether one can adapt the tools for something like this, or whether that's too far in the future.
No, it's not. I think that it is, and if you have something that you've been, what we're always looking for are examples, right? But like it's hard for me sometimes to explain to the devs.
No. I think that's what I'm getting to. I mean, we are gearing or doing a collection along the lines we'd like to use for alignment. So maybe when we get this data set or the beginning data set, we can just discuss with you whether that's something that you.
No, it definitely came up. We're on Avia 9.8, version 9.8, and we were releasing version 10 shortly. It definitely was a big part of the discussion, the alignment tool issue. It got passed, I think, on 10, so we're not doing it for 10, but it's been actively discussed. So let me circle back with you on that.
Great, thank you very much. I'll have my postdoc who may be on this meeting. I don't know, Katerina is on or not at this moment. She was.
Yeah, I'm here. Yeah.
So we'll contact you when we get the data set that exemplifies what the alignment would be on the project that we are undertaking, and then maybe we can discuss more concretely. Thank you.
Definitely, I like it.
As I mentioned, the NTS, we do have the package in the BTM 7th floor on a dedicated workstation. We do have the pixel classification, the machine learning, the package on it. And if anyone wants to just test on it, just let me know. And I also want to emphasize that, as Doug mentioned, that Aivia is kind of new, growing the products, and actually we'll see that they are willing to spend time with our users. Actually, on the multiple cases, they are actually individually working with our users on their data set, and then to generate what's the best protocol to analyze on that. So anything that if I cannot help you, you can directly check with the dog. You can send him your data set, and then we can always schedule some like the remote sessions to go on the system together. Getting?
Yeah, definitely.
So again, we're here so anything what we want is to have the more usage on the system, and the use on the software is free. And we're kind of very happy to provide this product to our user base. Yeah.
Cool.
So thanks, Doc, and thanks for everyone just joining the
Thank you very much.
All right. Thank you, Lai. Thank you, everybody.
Okay.
That was fun. Everyone have a great day.
Yeah.
Bye-bye.